Welcome back. We are going to try to solve problem number 3 now. Okay, so we have kind of looked at problem 3 before also, but we are going to solve problem number 3, not the same problem but the similar type of problem. So here, let's say given a transfer function g of s is equal to let's put 4 over s plus 4. Now, without solving the problem, we want to find out whether this, without taking the inverse Laplace transform of this, by taking what you call, let's say if I put a reference in, but let's say this is my plant, okay? So let me put it in here. This is my plant, and my plant is 4 over s plus 4, and I put this 4, okay? S plus 4, and I put an input here, R of s, and the input is a unit step function, so that would be equal to 1 over s, and the output is C of s. So that means your output now is going to be C of s is equal to R of s times the G of s, right? And here the goal is to find, first do the pole zero plot and see whether the system is going to be stable to begin with, right? Well, first of all, you can write this as CFS is equal to 4 over s times the s plus 4. Well, this is the response, isn't it? But if you do a pole zero plot of the transfer function, which is the g of s, you will see there is one pole on the left hand side of the plane, and that's minus 4. So you know for sure that the system is stable, right? Because there is one pole on the left hand side of the plane, which is right here. And you know when you have a pole on the left hand side of the plane on real axis, this is your real and this is your imaginary. So if you recall, the system is going to be overdamped. Okay. Now the question arises, how do you really find the response in the time domain? Well, that's where you will apply the partial fractions, but the good thing is you really don't have to find the values of the partial fraction. What I mean by that? What I mean is that this is equal to 4 over s times the s plus 4, and that will be equal to a over s plus b over s plus 4. Now you don't have to find the value of a and b, okay? So now you can directly take the inverse Laplace transform without getting the values of a and we can say, hey, the inverse Laplace transform, because a would be a number anyways, right? So the inverse Laplace transform of 1 over s is what? It's just 1, so you can write this as a, right? So the inverse Laplace transform of 1 over s plus 4 is what? E to the power of negative 4t, and then times the b. If you recall from all this discussion we have been having, you can recall that this is called the natural response. This negative 4t e to the power, that is called the natural response. Let me write this down here again. Natural response. And for the system to be stable as t goes to infinity, this natural response must go to 0. If it goes to infinity, then obviously the system is going to explode and you will have an unstable system. And this part that you're looking at is called the forced response. Forced response. Forced response. And as you can see, there is one pole on the left hand side of the plane on the real axis, and hence the system is an overdamped system. Overdamped. So this concludes our discussion for 3 problems so far. I have completed problem 1, problem 2, problem 3. And tonight, hopefully I'll make some progress either on problem 4 or 5 or both of them. Look at some stability criteria and look at some steady state error. Might take a couple of videos to do that, but in the meanwhile, if you have any questions for those 3 problems, please let me know. Send me an email or Skype or whatever you want. Thank you.